Hello, everyone. Let's begin. I'm happy to see you here. Thank you for coming. So for the purpose of this presentation, I'll be speaking English, but I do understand Russian, Belarusian, a little bit of Spanish. So if that is your choice of language, please just come to me during the breaks, and I'll be happy to speak with you. So today we'll be talking about GraalVM, and I need to show this slide before I go into any technical details. So we'll be talking about GraalVM, and to kind of set up the context for you, what it's like and what we'll be talking about today, here is this tweet that I saw recently, and I really liked it. What it says, in a nutshell, that with GraalVM now, you can use a Java compiler written in Java to compile another compiler written in Java down to native code. And this guy says that his mind is blown with all these levels of details. For me personally, it kind of reminds the movie Inception. Has anyone seen like the one with Leonardo DiCaprio? When you know there is like levels and levels of dreams and you don't even understand what is happening anymore. So this way to describe GraalVM kind of reminds me of that Inception movie. But that's like on the fun part of things. To talking about GraalVM more officially, to share some more details with you. In a nutshell, it's a new way of virtual machine. And what's new about it is that it combines all of these properties in one thing. So first of all, it's really efficient, and provides high performance for a wide set of languages, not just one language or common set of languages. Also, it is embeddable, meaning that it can be embedded in various environments and bring new capabilities and new tools to those environments. Also, it is multilingual, so not only Java or GVM set of languages or LLVM set of languages, there is so much more than GraalVM can do for you, and we will get to that in a second. And finally, it is secure, so it brings new opportunities of security, and I think especially it would be interesting for native languages where that can be a common issue. By the way, how many of you have heard about GraalVM before? So almost everyone, nice. How many of you have tried using it at your work or at pet project? Oh, I'm happy you're here. Please feel free to share your feedback with me afterwards. So the way it started is that it was started at Oracle Labs, which is this research and development organization at Oracle where I actually work. It started as a research project together with academic collaborators, and it was, I guess, 8 years ago, and there is this huge academic background behind it. So if you, let's say, during weekends prefer to casually read academic papers, we got a lot of those for you if you want to go really deep into this research thing. But if you want to just go ahead and start using it, I have great news for you. 2 weeks ago, we released our first production release. So it is a huge milestone for us. I think as developers, you understand what it means after years and years of development being ready to share this with you. And it is applicable for both Community Edition and Enterprise Edition. So if you want to try it and use it in production right now, it's right there waiting for you. What it can do for you, let's go into a bit more details. So you can think of it as a thing which sits in between languages and platforms over here, and it allows you to work with those languages and platforms simultaneously and use one set of development tools for the whole thing. And also it allows you to optimize the whole application, meaning that it will be more efficient and more performant. So to go into a bit more details, you can see that for start, we support Java JVM languages, and that is the regular default OpenJDK setup, which I think would be currently the most popular, the most famous use case for using GraalVM. Also, we support JavaScript with a high level of compatibility. We have our own JavaScript engine. Then we have a way of running applications written in Ruby, R, and Python. And what is interesting about that those languages run with high performance on GraalVM because our compiler is able to optimize this code really well. And another interesting thing is native languages. So you can run also native languages like C, C++ on GraalVM and benefit from the platform and tools that it gives you. Talking about context, we can also run normal Node.js applications, so you don't have to do any compatibility to bring them on GraalVM platforms. They will be working just the way they are. And you can use GraalVM in database, meaning that, for example, you can use your validation logic right in the database, and this way have more opportunities, more ways to work with your data. And the last but not least is a standalone mode, and what it means is that we can compile your application ahead of time into native binary, so it will be fully working, fully functional without any external dependencies. What you need to do will be packed into this binary, and everything you need will be in there, and application will be working just the way before, but with better startup and consuming less resources. So I guess it would be something that you would consider specifically for environments like cloud and microservices. So why GraalVM? Let's talk about its benefits a bit more. First of all, it allows you to have this great performance, and performance is something we all care about because neither we nor users of our applications don't like when it takes forever to run. Also, it is polyglot, meaning that all those languages we discussed before are supported, and even more, you can bring your own language on GraalVM platform. What you need to do is just to write your interpreter in Java, and you'll be able to bring it on GraalVM platform and run it in the environment along with all those platforms and with access to the tools. Also, it is embeddable, what I've talked about before, so you can enrich more platforms and more environments with the capabilities of other ecosystems and with tools from other ecosystems. And one part that I particularly like is that it's open source, so you can take a look on what's inside, see all of that contribution, and also the most part, I think more than 90% of the whole GraalVM thing is written in Java. So if you are dealing with Java daily, that shouldn't be too hard for you to understand how it works. And I think it's something like this, huge like this, must be interesting to look from the inside. So how is it achievable, how it is done, and where are all those properties coming from? How does this work from the inside? So you see that we have this like layered cake thing, and below there is our regular hotspot VM, and GraalVM compiler is kind of plugged into it, so they both work together, and that is how we bring on the platform Java and JVM languages. On top of that, there is language implementation API, which we internally call Truffle. So this is the way to bring more languages for us and for external developers to the GraalVM platform. Since they are all implemented through the common API, it's easier for them to interact, and you don't have this kind of performance penalties for bringing more than one language in your application. And on top of that, there are all those other implementations like JavaScript, Python, R, and later on we will touch on bringing your own language on GraalVM platform. So to elaborate a little bit on the previous slide more, here are the languages that we are using. And you can see this Solon thing that I haven't mentioned yet. So this is our LLVM interpreter, which we use to run LLVM languages on GraalVM. How to get started, where to go, and what to look for. So as a starting point, I recommend going to graalvm.org. If you want to get binaries, that would be a good point to start. Also, if you want to read documentation of getting started or to get some answers to your question, that would be a good point. And also, we are currently working on extending our community support, because currently you can join our mailing list or ask us questions on Gitter chat and so on. But we are working on interacting with community more, and we will be announcing this soon. So this website would be a starting point for that too. This is our GitHub repository. This one I'm showing here is our core repository, and also there are some additional repositories for languages implementations. So if you want to take a look on it from the inside, this would be your way to start. Performance, I've mentioned it like 10 times perhaps before, so let's dig deeper into that. So how is it achieved for GraalVM? First of all, we have our compiler, which is called GraalVM compiler. It's written from scratch. It uses new and more aggressive optimization algorithms. And this way, we are able to optimize your applications even more. It integrates with the hotspot VM, and it has this focus on high performance, and not only for Java or JVM languages like it was before, but on a wider set of languages too. The way it interacts with hotspot VM, it's like this, through JVM CI, which is JVM compiler interface. So you see that it's kind of currently modern approach where things are modular, interacting through interacting with each other through the interface. And it's kind of cool because this way you can understand the insights of compiler more to go through this part of virtual machine and understand how compiler works and maybe optimize your applications for better performance. So yeah, as I mentioned performance thing so many times, let's see what it looks like on a live example. So I have a bunch of demos right here, and let's start with this one. And I will show you what it does in a second. So it's a pretty basic benchmark, and we will run it in two setups, with GraalVM and without GraalVM compiler, and you will see the difference that the actual compiler brings to the benchmark. So I will just run it, and I will tell you what it does. So normally you would go like, if you want to compare how certain thing compares to your workload, you would run it, let's say, on your regular Java that you're using at work, and with GraalVM as another distribution of Java. In my case, for the purposes of moving quickly with the demo, I will run it on GraalVM 2 times. Just one time, I will disable the Graal compiler, and without the Graal compiler, our distribution would be just your normal, regular Java distribution with the hotspot C2 compiler, and you will see the difference that the actual compiler brings. So to disable compiler, I'm going to go like this, use GVMCI compiler, and then I will give it the actual benchmark, and we will see the performance difference. So yeah, this one, you see that I disabled the GraalVM compiler. This would be the regular Java setup. And let me also show you what it does. This one. So it basically, we get the bunch of ints over here. We perform some operations on them, and the setup of the actual benchmark is that we will have 1 iteration of warm-up, 3 iteration of the actual measurement, and the unit of measurement will be nanoseconds per operation, meaning that lower is better because less time is consumed for each particular operation. Let's see how our regular Java setup is performing. So we see, yeah, we see number, and the final number is 171 nanoseconds per operation. Maybe it's fast, maybe it's slow. Oh, sorry, on the last rows, do you see the bottom of the screen? Maybe I should bring it higher a little bit. So now I will use Graal compiler and run the exact same setup, and we will see what the numbers are. So yeah, this time we are running with GraalVM, and what do you think? Will it be faster? Will it be slower this time? Any guesses? Faster. Well, obviously I wouldn't show you the benchmark, which is slower for the technology that I'm working, yeah? But okay, faster, like how many? 10%, 20%? 50. It's a good bet, okay, I'll take it. Once again? 5? 5 times? Oh, okay, we are raising the bet. Any more ideas? Okay, but what about like 1% or 2%? I mean, if the actual compiler engineers would be in here instead of me, they would say that, well, you know, for compilers, even 1% or 2% is huge because compilers are such complicated things and it's not easy for them to optimize applications. I think they would say something like this, though I'm not myself a compiler engineer. Okay, we have the result. It's 9.8. Who remembers what was the number the first time? Yeah, so it's something like 19-20x faster with GraalVM compiler. Of course, here I have to say this very important disclaimer that before going with GraalVM, before moving your whole workload to GraalVM, please test it on your environment. Those numbers may not work for your environment. Like legal disclaimer, I have to say. But yeah, this kind of speed up is achievable, as you have seen over here, and the actual numbers will vary depending on the workload, on the machine, on this kind of things. But there is a decent speed up that you can get, and the best part is that this is something you get right out of the box, because you can think of it as a drop-in replacement. You are not dealing with the performance optimizations yourself. It is just something you take out of the box and can use right away. And by the way, it reminds me that there is even a simpler way to try one part of GraalVM distribution, which is a compiler. So if you are using Java 11, like latest Java bits, by the way, who is using Java 11 currently? Okay, a lot of people. So there is already built-in way to try GraalVM compiler. You just need to enable experimental options, enable GMCI compiler, and you can try how the actual compiler part will work for your particular workload. So that's one way to go if you want to try the actual compiler part. Let's proceed. So there is a bunch of optimizations that GraalVM, oh, way too much. So there is a bunch of optimizations that GraalVM performs. We have a whole blog post about it. You can read if you are interested into insights of compilers. I just want to stop on one of them, which is partial escape analysis. So in a nutshell, what it does, it analyzes if the object needs to be allocated for each particular thread, meaning it does not analyze the general global escapability of the object, but rather for each particular case. And this way, it's able to reduce allocations, because if it does not need to be allocated, we will just remove this allocation. But if this object is required in some other place, if it needs to exist in heap, then it will be created. But we have kind of more aggressive optimizations, so this way you can achieve this high performance optimization. Talking about other languages, for Scala, any Scala guys in here? Okay, you again, nice to hear. So for Scala, what we can offer is even perhaps better performance improvements, because Scala produces slightly different bytecode patterns, and our compiler is specifically good at optimizing those patterns. So if you're working with Scala, you can expect something like 10–15% of speed up with the community edition. And if you need even more performance improvement, you can go for enterprise edition and achieve even more. This is the use case, for example, that Twitter is using. If you've been listening to Chris's talks, he mentioned because they work with Scala too, and that is where they use the GraalVM compiler, the open source version. So for Scala, these are the average numbers from our article, and I think the most recent benchmarks show even better improvement. This is another benchmark that I wanted to share with you, which was published recently, and it's coming, once again, from the academic, from universities. So they have suggested another approach to benchmarking, and GraalVM performs really good in there too. Another thing that I wanted to mention here is polyglot programs, because that is something, I guess, when GraalVM was first published, generated a lot of buzz. Because how cool is that you can run your application in a few languages and don't bother about things like serialization, deserialization, and those language boundaries and so on. So the way that GraalVM approach is different here is that through the common API that I mentioned before, you can implement your own language or use the implementation that we already offer you. And as they are all on one platform and implemented using the same approach, they will work faster. So once again, to put it where it goes in the ecosystem, so thanks to Truffle, thanks to this application, Polyglot capabilities, we can bring even more languages on the platform. And this is something, for example, that you can think of when you want to run a bunch of languages in one application. But also, I know that perhaps the first idea you hear about this is that you would write your application from scratch in different languages. But we know that that's perhaps not the case, not the very common case, at least right now. What you can also do is just that when you need to add some new library to your already existing application, you can just grab it from another ecosystem and not rewrite your whole application from the scratch when you just need one library or one tool from another language ecosystem. How to enable more languages? You just need to add this one command line, because when you get GraalVM out of the box, it has things like Java, JavaScript, and LLVM runtime, because perhaps not everyone needs things like Ruby, R, or Python, so you can just install them and uninstall them as you go, and depending on what you actually need. Let's see how this Polyglot program looks like. Yeah, and by the way, I hope you appreciate my graphic design efforts. I'm not a designer myself, but I like Avengers movie, so I hope you like it too. I will show you this Polyglot program that we have. And I will show you what it looks like from the inside in the second. I just want to specify that I need to run it on the GVM, and that is going to be a Polyglot application. Yeah, must be good to go. Okay, so it's up and running, and let's see what it does. Yeah, and by the way, this is from the inside, the Polyglot part, what it looks like. So here you see that some common JavaScript things are in here. Also, we see the big integer part coming from Java, and here is the R part. So just to set a little bit of context, R is this language for things like data processing, statistics, data visualization, this kind of stuff. And what it's doing for us, it is building this cloud plot thing, and all of these three things like JavaScript, Java, and R are playing nice together to produce us this. So just to show you that I'm not fooling you and it's a real thing, I will update it, and you see that the cloud plot is rebuilding itself. It's not a PNG image or anything. So important thing to know here is that the very first request is going to take slightly longer, because we need to initialize 3 language contexts. But other than that, you see that I updated the page and it worked really quick. It's just that with Polyglot application, we just need a bit more work done on the very first step. But this is the way it works. Yeah, going back to the slides. Another big topic is native images. So native images is our way of calling the native binaries we produce ahead of time. So you can think of it as of your regular Java application, which does exactly what you are planning to do, but it does it being precompiled ahead of time, meaning that you will have this instant startup and also low memory footprint properties. And what is good about it is that, for example, if you are working or planning to work with cloud, instant startup, and low memory footprint, this is what you need when you want to scale things back and forth, so you would be interested in that. The way it works, that your normal setup would be the hotspot part would be precompiled ahead of time, and then you will have a part of code dynamically executed. Right now, everything will be precompiled ahead of time, and all of that will be put into this final binary. And the way it works is that we take your application, we take all the classes you need from the JDK, we perform analysis of it, starting with the main method, analyze what is reachable and what needs to end up in the final application. Then we optimize the whole thing, and it ends up in this native binary. And what is also important, this native binary has kind of little implementation of virtual machine inside, which is called Substrate VM. So it can work with things like memory management, so you don't have to take care about them. One more demo of the native image thing. I want to show you how it works, how you do it, and how good the startup is. So what I have over here is this simple application, which is called listdir, and it's a very basic one. It just walks the current directory, looks for the files in there, and outputs the information like how many files it has found, what is the total size, stuff like that. So what I can do, I can build a native image of it. This is the actual native image command, and I need to give it the actual Java file, and it starts doing the things that we've seen before, like starting from the main method, analyzing what's reachable, what needs to be in your application, how does it need to work, and then performing things like static analysis and optimizing and outputting you the binary, writing it down to disk so that you can use it. So, and you can see all of these steps being performed one by one. So important thing to remember here is that you can think of it as of splitting your application development into building the actual build time and the actual runtime, and the more stuff, the more time and efforts you can take from the runtime into build time, it will be better for your runtime, because that is the way your application will be running faster, because everything you can do before that, before running it, will be done before, so it will start really fast. So to compare, I will run the regular version of that application, and we'll time it, and we see what it does. So it have found 8 files, and here is the time it was needed for this application to perform. And now I will run the native binary that we'll build. So you see that they did the same thing. The output is the same, but the numbers of time of starting are order of magnitude different. And that is thanks to compiling it ahead of time. Talking about native applications, native binaries, this is one more example that I have. So you can see GraalVM native here is in green, and the regular GVM setup is in blue. And the green one you can barely see on the top chart because it's so small. So in terms of time, the speed up is just crazy, and in terms of resources consumption, it's slightly bigger comparing visually, but anyway, it's much faster than the regular JVM setup. One more thing, talking about native images, I guess you have heard about Quarkus framework, because I feel like all the conferences that I checked recently, there is a Quarkus talk, so I assume you have heard about it. So they are also using native images, and what you can see over here on this chart is the numbers of how Quarkus performs with GraalVM, with OpenJDK, and traditional cloud native stack. So GraalVM is here in this bright blue color, and you see that numbers are really, really different. The speed up is very prominent. Also, I want to share with you recent project updates, because since our first release, it's been a year, and there are just a few things that I want to stop on. So libgraal, talking again about the Inception movies. So libgraal is our version of GraalVM compiler, pre-compiled ahead of time using our native images thing. So before libgraal, Graal compiler would be written in Java, and it was needed for it to compile itself at the first, and then it could compile other things. Right now, it's compiled ahead of time using native images. So right now, it starts faster, and you have additional performance benefits. For some time, it was additional option you can enable, and right now, it's a default option since RS16, I guess. So if you are using latest GraalVM bits, GraalVM compiler will be coming for you in the form of libgraal. Also, isolate is another big update, so you can think of it as of several independent virtual machine instances running in the same process without interfering with each other. We have a whole blog post for that if you would be interested more. And yeah, we are working a lot on simplifying working with native images for you. So recently, we wrote about this Maven plugin for you to work with native images, so it would be even more easy and comfortable for you. Talking about ecosystem adoption of who are working with GraalVM right now, what is the adoption, what are the possibilities for you. So I will mention the Quarkus thing for you. Also, the Spring guys, I guess it was last week that they announced native image support coming for 5.3 version. Also, Micronaut guys are working on native images support too, and a few more things, a fan project for serverless and Helidon project for microservices, where we are working together to extend the support that we offer. A few more things about use cases. So perhaps you have heard Chris talking about Twitter using Graal compiler and what they get out of it. There are a lot of talks. You can listen with specific numbers and also with additional tuning options that Chris uses to increase the performance even more. One more example that I like is coming from Goldman Sachs. So they have their own in-house written programming language, because back when they started this whole digital products thing, it was 25 years ago. So most of the languages that we know were not present back then. So they have written their own in-house language, and now they're trying to kind of evolve it and bring more modern tools to it and bring it on the GraalVM platform. So to summarize why GraalVM, what you can get from it, and what is achievable for you, first of all, you can have faster Java and JVM application, and you can think of it as a drop-in replacement where there are no additional efforts needed from your side. Also, you can get instant startup, low memory footprint with native images. Also, additional capabilities for your environment that you're working with Polyglot and embeddability options, and interoperability between a wide set of languages, and we are planning to bring even more languages on the platform, so there will be more news coming. And yeah, please try GraalVM, and if you have feedback for us, please share with us. The easiest option would be to pin us on Twitter with hashtag or mention. Also, we have a mailing list you can subscribe to, our GitHub repository that I've shown to you, and Gitter chats where you can chat specifically with our team and ask the question, and maybe if you have an issue, you can report it and talk to our team. So that's it. Thank you, and please come talk to me if you have any more questions or just would like to chat. Thank you.
What about drawbacks of GraalVM? Is there any problems, risks, or whatever?
Okay, so GraalVM is, you need to put it back. Maybe if you can just hear me, I'll try to speak real loud and you'll be able to hear me. So talking about drawbacks, maybe I'll just speak like this. Okay. So talking about drawbacks, as with every new technology, I guess you would need to evaluate it first. So if you wanted to try it on your particular workload, if you want to use it at your work or for your individual project, you would need to try it first. And it really depends on your workload. I would say that there are different cases where you can use GraalVM. So if you are running some high-load application and you are looking forward to peak performance, that is the most crucial part for you, I think it will make sense for you to start evaluating with the regular JIT setup, where GraalVM will be working in just-in-time compilation mode, because that is what Java is well known for and where its main strengths are coming from. So that's talking about high-load, peak performance applications. So I would say that GraalVM has these different use cases for different situations. If you're looking into instant startup more, and that is what's crucial for you, the way things are starting and scaling, you would want to look more into native images thing, because they are specifically tailored for instant startup. So I would say it has different capabilities, and it's a matter of particular use case of what would you like to try, because there is so much things and so much scenario you can try it in. Did I answer your question? Yeah, go ahead.
Thank you, Alina, for your talk.
Thank you. Thank you for trying GraalVM.
Yeah, about 4 months ago, I built a native image out of simple command line closure application.
Okay.
Yeah, and at this time, GraalVM, well, at this time, like at least native images like had these severe limitations. Well, I mean, was forced to replace my HTTP client implementation, because I wasn't able, for some reason, to like establish HTTP connections or SSL. So what the state of the native image at this moment?
Yeah, that's a good question. So native images itself, I guess you would agree that it's kind of rather technology that has changed a lot. It's quite uncommon comparing to what was available before. So yeah, it takes additional time to implement it and to make it in the way where we would expect it to be. So yeah, there are certain limitations and certain trade-offs when you are working specifically with native images, but we are working on eliminating those one by one, and there is another big announcement coming in the upcoming weeks. I can give you this kind of teaser thing. So we are working really, we are putting a lot of effort into making native image compatible absolutely with everything and for each use case. It's just that with things like this, there is always a trade-off. Like you can eliminate some limitation right away, but you would need to, for example, to give up a certain time regarding startup or speed up. And we don't want to build something in between, which would be starting apparently slow, but also wouldn't have any limitation. Like we decided for ourselves that we want native image always to be absolutely top in terms of startup and memory footprint, and we don't want to compromise on those things. That is why we are looking for ways to eliminate those limitations without giving up the benefits that we are focused for. So we will eliminate them one by one, but it just needs a little bit more time. And since you've been working with native images, I guess you know that there are limitations, but there are also workarounds around them. Like you can provide special configuration file for each of these limitations, and you can make them work for you. So the state is that they are currently coming in the latest production release. They included in the latest production release. It's just that we are still working on eliminating those limitations without giving up the startup and memory footprint benefits. You're welcome.
Thank you for your talk.
Thank you.
I have very pragmatic questions. So imagine I'm a real practitioner, Java developer. At what is the easiest way to start working with GraalVM in my current environment?
So in your current environment, if you are looking only for a way to try out compiler, let's say, and if you are using one of the latest bits, like 10 or 11 Java, you can use it right away in your setup. It is just right there. It's just not a default option. You need to enable it with the command lines. So you can use GraalVM compiler right away. But that's only one part of the GraalVM as a whole, as we have been talking about today. So if you need just a compiler, if you want your regular just-in-time setup to be more performant, you can use compiler right in your latest distribution of Java. If you want to move to GraalVM as a whole, because you are also interested in things like Polyglot capabilities or native images thing, then you will need to move to the GraalVM distribution.
Okay, and is it included in Java 11?
Yeah, the compiler part is, so you can enable it.
Okay.
You can come to me afterwards and I will show you the way.
Okay, thank you.
Thank you for your presentation.
Thank you.
So I wanted to ask what the difference between community and enterprise versions of GraalVM.
So community, they both have been released recently in the production release that I mentioned. So both community edition and enterprise edition are production ready. What is the difference is that community edition is open source. You can use it right away without any licenses, and it is free for you to use and ready for production. The enterprise edition requires license to be used. And what is the difference is that if you are working on some enterprise thing and you have tested, let's say, community edition, and you see some improvement, but you want that improvement to be even more, then you might want to switch to enterprise edition. So it's just what you are looking for. I saw this tweet recently. I don't remember the author, unfortunately. So he said that his way of understanding things is that if you want a certain level of performance improvements and access to all the capabilities like native images and Polyglot, you can use Community Edition. But if you want to use it with even more performance, if you are not happy with what you get with Community Edition because your environment is requiring even more performance, then it's fair to switch to Enterprise Edition if the Common Edition benefits are not working to your expectations. So that's the difference. Thank you. Any more questions? Oh, okay. I guess that's it.